Section 2.7 is about graphing inequalities. We've already looked at graphing linear equations that have equal signs, but now we're going to graph linear inequalities that have less than, greater than, and equal to symbols. The only difference is that when you graph the line, you have to determine which side you're going to shade, and you're going to color in one side. Now that line that you're going to graph is called a boundary line. That's a line that divides a coordinate plane into two half planes. Now when you graph a boundary line, there are two kinds you can graph. You can graph a solid line, or you can graph a dotted line. Some people call it a dash line. Now it's going to be solid when you're using symbols like greater than or equal to, less than or equal to. And it's going to be dotted if you're using greater than or less than without the equal to sign. So be aware of when you're going to have a solid boundary line and when you're going to have a dotted boundary line. So let's jump into an example and graph this inequality. I think the easiest way to do this is to temporarily replace the inequality symbol with an equal sign as you mess around with this equation, because you're going to graph the boundary line. I want to get the y isolated, so I subtract 2x from both sides. And I like to put it in slope-intercept form, so I put the x value first, and then I'll divide everything by 3. So y equals negative 2/3 x plus 2. So this equation is the equation of our boundary line. To graph this equation, we can plug points in, or we could also use slope and intercept. It's easy enough here to use slope and intercept, so I'm going to do that. My intercept is 0, 2, and my slope is negative 2, 3. So I'm going to go down 2 to the right 3, down 2 to the right 3, and I'm going to graph my line. Now what kind of line should I graph? Go back to what we said here. It's solid if it's got an equal to line underneath it, and it's dotted if it doesn't. Well, this original problem, does not have an equal to line. It's going to be a dotted line. So there's my boundary line. Now the last thing to do is to determine shading. And the way you do that is you try a point that's on the left side of the line or a point that's on the right side. And you can pick any point you want. I always like to pick 0, 0 if I can, because I think it's the easiest point. 0, 0 is right here, and I'm going to plug it back into the original inequality. 2 times 0 plus 3 times 0 is greater than 6, which means 0 is greater than 6. Now, is that a true or false statement? Certainly it's false. 0 is not greater than 6, which means the 0, 0 point is on the bad side. It's on the false side. So I don't want to shade the left side of this dotted line. I'm going to shade the right side. So you're going to give a light shade with your pencil on the right side of the line, and that means that all of the points that are over here in the blue shaded area will make the inequality true. All of the points that are here on the left side of the non-shaded area will make the inequality false. Here's a real-world situation that we're going to graph as an inequality. It says a mail order company is hiring temporary employees to help packing and shipping departments, and they have 20 temporary employees available. So my two unknowns, the two things that I'm looking for, is how many packing employees and how many shipping employees. So I'm going to use P for the number of packing employees, and I'm going to use S for the number of shipping employees. So my inequality, since I have 20 maximum, I'm going to be less than or equal to 20. And if I add the packing plus the shipping, I've got to come under 20. So there's my inequality that I'm going to graph. Now, because there is no independent and dependent variable here, it doesn't matter which one of these I use. I just need a couple of points that I'm going to graph on here. So I'm going to use the intercepts. So I'm going to make a temporary boundary equation. And if I plug in a 0 for P, I'm going to get a 20 for S. And if I plug in a 20 for P, I'm going to get a 0 for S. So those are going to be some points that I'm going to do. And now I have to put those on the graph. I'm going to put packing employees on the bottom. I'm going to put shipping employees on the side. And I'm just going to go by 4 here. And my ordered pairs then are 0, 20 and 20, 0. Because it's less than or equal to, my graph is going to be a solid line. And now I've got to determine which side of this line to shade. So I'm going to try 0, 0. I always like to try 0, 0. So we say 0 plus 0 is less than or equal to 20. Is 0 less than or equal to 20? That's true. Which means 0, 0 is on the true side. So I'm going to shade down here on the true side. which means that any combination of employees that's in here, like 12 packing and 4 shipping or so on and so forth, any combination in the blue area will work for this company, but any combination of employees in the non-shaded areas will not work. Here we have an absolute value function. If you remember, we just learned about absolute value functions. So when I make my boundary equation, you might even remember how to graph this with the +1. If you remember, the +1 means I'm going to have my absolute value v is going to go through the y-intercept of 0, 1. Now I'm going to give you some points still, just in case you don't remember this. I'll give you a list of points so you can graph this. -2 becomes a 2, +1 is 3. 1 plus 2 is 2, and 3. So let's go ahead and graph this. Now before I put my lines on here, I have to go back and see that it's a less than, which means my absolute value function will be using a dotted line, not a solid line. So here's the v that we knew was going to happen, because we know what absolute value functions look like. And the last thing we have to do is we have to try a point to determine the shading. So I'm going to try 0, 0. 0, 0 is below, and I'm going to put it back into the original function. So 0 is less than the absolute value of 0 plus 1. That is a true statement, which means 0, 0 is on the true side, so I want to shade everything that's below this boundary line. So here's what my graph will look like for the absolute value function.